Then the next step in the process we move into is pre-filtration. Now there's a whole industry making pre-filters. Some of them are made here in the US, some of them are made in Germany and imported. These are some examples of them. They come in various sizes, from the one in the middle, I think can handle up to 30,000 square feet of roof. In a type 2 event, which is a much more intense rain event than we have around here, are more mellow type 1A events, less intense storms. This filter in our climate could probably handle much more than 30,000 square feet. So that's the more complex ones, and they work really well. They work by a principle of adhesion. As the water comes in, for example, that middle filter there, it goes centrifugally around that filter, and by adhesion, the water sticks to and flows through the screen on the basket and out to the left in that example. And the sticks and the debris that can't make it through the screen by adhesion fall through down the bottom and go out the bottom. So that's the more robust. The one on the left is the simple inclined box design, where we just put a 16th inch bug screen on there on a little wedge shaped filter, and so rainwater will fall through the filter and the sticks will fall off, and it's just kind of a self-cleaning, very simple filter. So, and then the one on the right is the same principle as the one in the middle, but just a different shape. I did also want to mention the concept of a roof washer. You'll see this notion of a roof washer mentioned in a lot of design guides online, like the Texas Guide to Rainwater Harvesting. A roof washer is a device that diverts the first X gallons from the roof away from the cistern. And a roof washer works really, really great in Texas, where you've got these high intensity, short duration rain events. Oh yeah, let's take the first 50 gallons of the storm and we'll divert it by a little bucket that fills up, or a float, or we'll just have a little plug on the bottom. This little sump will fill up, it'll constantly drain. Although it's becoming less common now in this area. You used to see a lot of jurisdictions around here reading the Texas Guide to Rainwater Harvesting and say, we need a roof washer here. But around here we have long duration, low intensity rain events, and roof washers waste too much water, in my opinion. They're not practical, not advised for our climate. Pre-filtration down to 100 microns is the way to go in our climate. And now moving into the visible part of a rainwater collection system is the cistern. A couple of key requirements, of course, structural. They usually require a building permit. They need to have the integrity to meet seismic and any earth pressures if they're below grade. Need to have a good base and take all the structural issues into account to make sure that the cisterns don't move or fail in some way. Access into the cistern is typically advised if they're of a certain size to be able to get in there and clean them, so having an access port. Having a bona fide overflow so that the cistern can overflow and be directed to your stormwater system where it can be properly managed, dispersed, or connected to a BMP like a bioretention or a rain garden. And the cisterns really need to be isolated from each other to be able to drain them down for maintenance. All penetrations into the cistern, be they vents, need to be screened for vermin and insects, and that typically means stainless steel mesh on all your vents to keep the critters from getting in there and the bugs. And then lastly is freeze protection. And freeze protection in our climate, for most of the cistern sizes that I use, we don't have cold snaps long enough to freeze solid 3,000 gallons of water. It's going to be a designer's choice to figure out when you're concerned about that, about how small of a cistern you're concerned about it freezing solid. For systems of the most of the scale that we're going to talk about today, it's not an issue. Whether you want to do a little bit of insulation on your more smaller cisterns, that could be advised if your cistern can't take freezing. All the pipe connections need to be below grade. They're going to be highly prone to failure from freeze thaw. So we absolutely want all our pipe connections to be buried or otherwise freeze protected. But by and large, the cistern itself is not really a concern because of our more temperate climate. Now we're going to kind of roll through some examples of various cistern types so you can see the range. The one on the left, actually a precedent-setting design for King County. That was the first sole source permitted rainwater capture system for a single-family residence in King County. And so that guy there is Gary Ammett, and he really wanted to do rainwater capture for his house in Carnation and did not want to connect to a well. And so pursued that process through King County and was able to successfully become the first potable sole source rainwater system, and subsequently many other people have followed in that case, and King County now has a policy to allow rainwater capture for sole source. And then on the right is the 35,000 gallon tank that I mentioned was out on the Lopez Zero Energy Project. They look about the same size, but the one on the right is much bigger than the one on the left. And the one on the right, the conveyance to that tank is actually all below grade because the houses are all above. So we had sufficient grade. We used the flattest tank, like a pancake, that we could to get the grade low, but the overflow flow of the tank was below the footing of the next house. This is out on Lummi Island at the Community Land Trust project, where each home has got 3 of these pallet-sized tanks. So for the 9 homes, and then each one has a little shallow well jet pump and a basic filtration that's supplying their toilet and their cold water leg of their laundry and a little bit of irrigation. So the one previous was a community system where one centralized tank for 14 homes, and each home had a water meter for rainwater and a water meter for drinking water. This little community wanted to do it differently. They wanted to have each home had their own system, so there was a clear maintenance. Each home would just maintain their own system. There's different ways to do it at that kind of community scale. Above grade plastic tanks of various types. The one on the left happens to be the project I mentioned back in '99. That was the first system I worked on. Rather than doing the wet pipe system, we did the overhead distribution, which I've only done that one time. There's different ways to do it, but that's the way we chose to do it on that project. We also did an inline screen. This was back 16 years ago. There were no filters on the market, so we just used a typical plumbing strainer. Then there's, the one we mentioned in the middle, the little 300-gallon tank out by the Arboretum here in Seattle. Or there are these now more purpose-built cisterns that are, instead of being round, are flat, and they're kind of ideal for being alongside a building. These are called Bushman tanks. Below grade tanks can also be plastic. Typically they're polyethylene. There's different vendors out there. Or certainly below grade tanks can be cast in place concrete. This is a project in Seattle which had a cast in place tank that we turned into the patio for the house. There's a view of it under construction. There is a finished, and then there's a little view inside the house showing the little strainer system with the little float switch there that cuts off pump when the water level gets low. Or precast concrete. This is from a project down in Eugene, Oregon at a Lane Community College, new downtown campus. 2 20,000-gallon tanks here to supply toilet flushing in this academic building, and so we used precast concrete tank there, a utility vault system. And these tanks all have different price points. We didn't mention the one in the kind of middle upper left there, which is a bladder tank, which can be used in a crawl space. I've done that one time at a project up in Scenic where we had freezing conditions. I was actually concerned that the tank was going to freeze because we were way up in the mountains, and so we stuck it in the crawl space using a bladder tank. And that the bladder tank was actually a pretty reasonably priced option. It was interesting. And so you can see there right on down to below grade fiberglass. It costs more money, but of course you can store a lot of water underground and can be a great choice for a project. Getting right into then, now that we've collected the water from the roof, we've got it in our cistern. Now it's a question of starting to pump and distribute that water out to whatever use. Again, mentioning freeze protection, we want to make sure that our plumbing connections to our cistern are freeze protected below grade. There's a couple different ways that you can provide the suction inside the tank. Typically, these days, almost all my systems are using a floating suction system, like your floating strainer, like you see there. So that's a plastic float, and then you see another little cylindrical screen there, and then that flexi hose connects to the bottom of the tank and off to the pump. We're always pumping from about 6 inches down from the surface of the water, so we're not picking up any floatables. We typically cut the pump off with about 6 inches of ponding in the bottom of the tank, so we're not sucking any dirt off the bottom of the tank as well. You can also certainly have a static inlet. That's fine. It's certainly commonly done, although I think more people are moving to the floaters, but you set a fixed inlet like we saw in the previous picture, one of my older designs where we had an actual suction line, and that suction line is set 6 inches off the bottom of the cistern, so we don't pick up any sediment that may have settled there. We also have float switches in the tank, typically that kick the pump off when we get down to that level, so that the system goes dry, pump's cut off so we don't burn our pump out, and if we have a backup, we have another float switch which opens up our solenoid valve on our backup supply, usually right around the same time. Calming inlets, but when we introduce water into the cistern, we typically want to do that with an upturned elbow or something to reduce turbulence, so we don't kick the sediment off the bottom of the tank and introduce it into the water column. Like a pipe comes down, and then we just have an upturned elbow, or we can also have a stilling well around the inlet where there's a larger 8 or 12-inch pipe that the water comes into and that is more turbulent. It's just not subject to the settling. So either one of those would work. Pumping. Pretty much from this point forward in the system, all of the components we're going to talk about are routine, common components that are in most residential well systems. So all this stuff is not exotic, not rainwater specific. So we're talking about shallow well jet pump is my preference. The one on the right where the pump is outside the tank so you can work on it. The one on the left is a submersible pump that is on a mounting plate so that it can actually be, this pump can be inside the cistern. That's certainly a fine way to go. It's not my style. I've always gone with pump outside so you can see it and work on it and stuff. But having a submersible pump inside the tank is certainly, and especially if it's in one of these kind of housings that are purpose-built, that's fine. The controls, you can go single speed pump with a pressure tank, or you can go, my preference is a variable speed. This little pump in the lower right is my kind of go-to pump for all my rainwater systems. It's a very reliable approach, a very simple approach. It's a variable speed drive so that the pump will ramp up in response to the demand. You don't have to have a pressure tank. So it's just more space efficient. And then filtration. Most of the residential and even some of the small commercial systems are just fine with cartridge filters of various types, like you see there on the left. And then as you move up in system size and volume, you go maybe into a sand filter, like from a pool. That's what we used out at Lopez with a slightly different media than it came with to get to the filtration level that we want. They're self-cleaning, backwashing pool filters. They go into a backwash cycle automatically. Or manually if you don't want to pay for the automatic, and they are just self-cleaning, and that can be a really nice system at the community scale, or right on up to bag filtration, which is more of a commercial scale. It just depends on what flow rates you're talking about, because each of these filters is going to have a certain flow range and a certain head pressure loss that will be with each filter. So this is a typical example of a very simple residential non-potable installation. Happens to be in the basement of that house where you saw the cast-in-place tank. So we happen to have a basement access, so we're able to put this pump just right on the basement wall. These little jet pumps can lift water up to 15 feet, so they don't even need to be down at the bottom. They got a little pressure tank on them just for kind of incidental, I think, for pump start up and stop. You can see in this case we also have, you can see the pipes, the distribution pipes are purple. We'll talk about that in a second when we get to kind of the code. So that's an example of how simple rainwater capture system can be for a home. Those pipes just go to the toilets and to the hose bib, and that's it. So to give you the setting for this Lopez project that we've been talking a bunch about, here are the homes, 14 homes. You can see in the upper middle there is their Group A water system. For potable, there's their tank, their well house. There's the cistern. We also had a detention pond here. We also used the bottom part of this detention pond for dead storage for another year. We got a water right on this project for irrigation, which we drew from the pond, and then we used the rainwater collection from the roofs for the toilet flushing. And so this was a hybrid detention rainwater pond with a water right. You could see the outlet control structure there. It has its own well house there, and that system supplying all the non-potable to the 14 homes. Their pump is sitting there on the floor. You can't see the second pump. And then there's that pool filter I mentioned. And so that's an automatic backwashing pool filter, so that just filters down to 20 microns. We do have pressure tanks in that case. We didn't use variable speed drive, so we had a duplex pump and some pressure tanks. On potable systems, we're going to be bumping up the filtration to a higher level of filtration. We usually go to 20 or 50 microns on a non-potable. On a potable system, we're usually getting down to at least 1 micron or below half micron, and we're usually getting some carbon involved at one stage in the process for aesthetic reasons, taste and odor. But it's the similar type of cartridge system on a home system. It's not particularly exotic. The one different piece is we use ultraviolet light for disinfection. And that's an example on the right of a little residential scale UV system of the type that I commonly use on my design. And they come in various flow rates, and you'll see some examples of how they kind of go together. So the pollutants of concern that we're interested in dealing with on our potable systems are all of the usual constituents that are on the Department of Health list for when you do a typical well test. However, most of those constituents are not typically going to be found on a roof. There's a lot of pesticides and other issues that are not likely going to be on your roof. That's drinking water quality standards. We meet the same drinking water quality standards as any drinking water system. It's just that the things that we're likely going to find up there is actually very little, but it may be some metals and things related to the roofing, and maybe some coliforms from birds, some sediment, that sort of thing. Of all the testing that I've done on all my potable rainwater systems, we really don't find much. I honestly thought we'd find more from atmospheric deposition of stuff. And even in the case of that first one back in 1999, which is actually near an oil refinery, we didn't even find a lot there. We did a lot of testing and really we're pretty satisfied with the quality going in and certainly with the quality coming out. So here's an example of a potable system where you've got the additional levels of filtration from non-potable. You can see the little jet pump there on the floor. You've got your initial sediment filtration, and then you can see I jumped to 2 filters for the last stage because it's getting it down below 1 micron carbon filters. So those filters just have a lower flow rate. So we needed 2 of them in parallel to meet the flow, and then we go through UV disinfection, and then we're off to distribution within the home.